Serverless computing is the need of the hour and it is here to stay. When you talk of serverless computing, it is the process where your service provider owns the servers and allocates resources to you dynamically, where you don't have to worry about managing these resources at all. Now, in this session, we would be talking about serverless computing and Amazon Lambda in particular. Let us go ahead and take a look at the agenda or the offerings of today's session first. So we'd start off this session by understanding what serverless architecture and serverless computing is. Then we'd move on to understand how Amazon Web Services provides you with serverless offerings and services. Next, we would go ahead and understand Amazon Lambda service and other services that AWS has to offer to you. Then we would get into the demo part where we would understand how to build a serverless application and what containers are. Finally, we would finish this session by understanding who uses serverless computing and what are its use cases. So I believe this agenda is clear to you guys. Let us go ahead and take a look at the first topic of discussion.
So today's agenda is going to be introduction to serverless architecture, and we'll be talking about the AWS serverless platform, and then we'll be building a serverless web application. I'll be walking through two use cases as part of this demo. First is introduction to serverless. So this is how the evolution of serverless or the cloud computing, I would say, right? Ages back, when we were having our own machines, I'm not sure whether how many of you have experienced that era of where your website have been hosted from your own office backspace with a fully air-conditioned server room, having separate servers from where your web server or database server will be running, right? So from that era, we transformed into a data center world, and we were really happy when somebody is there to take care of the infrastructure for you. You don't have to worry dealing with that. So it started with data center, and then it moved up the clock with servers, somebody providing infrastructure as a service for us. And then we moved on to having platform as a service. The application will be hosted, the infrastructure will be managed. All that you have to do is use the application, right? So platform as a service came in. And then later, containers is a big thing with the evolution of Docker and stuff. Containers as a service was a big boon to us. And now, like since 2014 or 15, when the Lambda was first launched, I think serverless is a big thing, right? So everywhere people talk about serverless. What is that serverless myth? So the service, basically, as far as Amazon Web Services is concerned, EC2 instance was launched way back in 2006. And since then, it was continuous improvement and evolution of new services or enhancements to the existing services and so forth. It was going on and on until 2014 or 15 when the Lambda was introduced, right? So now, like since then, there's no looking back. There are a lot of people who have felt what is serverless, how it's going to be. It's all now being behind serverless. They've started using serverless platform left and right for predominantly all of their workloads or majority of the workloads. So we'll see what it is. For now, just tag or term serverless to be a function as a service, and we will see more in the coming slides. So here is the evolution from data center to the serverless world. How it's going to save us, right? With the server world, when we are taking care of servers, building our own servers, there are a lot of mysteries around it, right? You have many open questions. Here is the open questions, and they're endless, I would say. What operating system to use? Is it current? How many servers should I budget for? What if my hardware fails? Is it highly available? Who's going to take care of software upgrade? How often should I do that? These questions are certainly endless, right? So with the advent of serverless architecture, we are saved from many of these questions for part of our workloads. We'll see how and what portion of the workloads. Of course, for everything, you cannot go serverless and get rid of servers, literally, but there are many things for which you can go serverless, right? So what is this serverless? What do you mean by serverless? It's a buzzword, right? So does it mean no servers? Without any servers, of course, nobody can do anything. We need a machine, right? Whether the machine is in front of you or elsewhere, whether you manage or somebody else manage, all that you need is you need a machine to do something what you want to do. So what is serverless? Here is the little definition. The serverless is the native architecture of the cloud that enables you to shift more of your operational responsibilities to AWS, increasing your agility and innovation. This literally means the servers are abstracted from you, enabling you to focus on your day-to-day tasks and deliver things quickly in an efficient or a better way to the end user. So the abstraction of servers and all the headaches that you have to deal with servers are taken care by a third party. Here, Amazon Web Services. So that's what the serverless architecture means. So what is the advantage of going serverless? There should be some reason, right? When you wanted to go serverless, it is fully managed. You don't have to provision 10, 20 EC2 instances to do that. There is no administration effort when you don't have to provision a server, and it is highly available. You're going to have increased productivity for sure. How do you achieve that? Because since you don't have to manage the servers, you're going to focus on business logic or the actual code, and you will continue to innovate rapidly. You employ your resources to innovate rapidly so that they can work on more features to deliver to the customer, thereby reducing the time to the market, right? So this is how you're going to increase the productivity by going serverless, and it's going to abstract the servers from us. We're not going to deal with that. All that probably you would say is how much memory you need. That's it. So it's taken care. It is completely event driven, can scale instantaneously, and they're built based on sub-millisecond. Probably when we go into Lambda and the billing, we will see how this millisecond billing is done. So with all these advantages, we'll move forward to see what is an AWS serverless platform, right? Most of you might have heard of Lambda, right? So is Lambda only the serverless thing from AWS? So we're making sure we are recording. Yeah, recording is going on. Okay, so now we will see what are the serverless services that Amazon provides. Under compute section, we have AWS Lambda, Lambda Edge, and AWS Fargate. So Lambda, we all know that it'll let you run code without provisioning or managing servers. You treat Lambda as a function as a service. You define a function, keep it aside, invoke it as you need, and it just runs. Where it runs, how it runs, it's taken care internally by Amazon Web Services. That's why we call it as a function as a service. And this Lambda Edge allows you to run Lambda functions at AWS Edge locations in response to CloudFront events. And Fargate is a serverless stuff for your containers. Amazon S3, we know without S3, there's no life in Amazon Web Services to store whatever you want to and whenever you want to, right? And EFS is the Elastic File System under storage section. And under the database side, we have two things, Amazon DynamoDB, and under RDS, the first thing which went serverless is Amazon Aurora serverless. And under API proxy, we have API Gateway. There are much more services. Under processing or messaging side, we have SNS, simple notification service. Amazon SQS, it's a simple queuing service. SNS is a fully managed message service that makes it easy to decouple and scale microservices, distributed systems, and serverless applications. What is SQS? SQS is a fully managed queuing service, and we'll just see what is it by name. We're not getting into the details of it. I just wanted to let you know the AWS serverless platform is vast and it has huge list of services. We have AWS Step Functions. Under orchestration and analytics side, we have Kinesis and Athena. And in the developer tooling side, we have frameworks, CI/CD tooling, monitoring, and so on, right? CI/CD, you have the whole suite is serverless. CodeStar, Code Pipeline, Code Build, Code Deploy. See, these are the plenty of serverless services available with serverless Amazon Web Services serverless platform. We will get into the details of 4 serverless services that we will be using in today's demo, because 2 hours will not be sufficient if we talk about all these services. So we'll get into the services which we will be using it today. In today's demo, while we building our sample serverless web application, we'll be using Amazon S3, Amazon API Gateway, AWS Lambda, and CloudWatch. So we will just see at a very high level what these services are. S3, most of you might be already familiar. S3 is the massive storage service which is available with Amazon, and it comes with different storage classes like standard S3, infrequently accessed, your Glacier, so all that. So based on your need, you can go for it. Even Glacier is now with the Glacier Deep Archive. You also have Amazon S3 standard with an intelligence that it will automatically take care of moving it from one object storage class to another object storage class with minimal automation or movement fee for it. So in Amazon S3, you can make the objects publicly available to people. You can host static website there. So as part of our example, we will see how we are going to host the static website in Amazon S3, right? So it is the storage for internet. It is highly scalable, and you can store object sizes ranging from 1 byte to 5 terabyte. And in a single upload, you can upload up to 5 GB, and more than 100 TB, it's always recommended to do a multi-part upload. You just split it and do a multi-part upload, or you don't have to split it. If you do a multi-part upload, it's automatically split, uploaded, and united there. You can go for Glacier if you want a low-cost storage for a very long term. And you also have Glacier Deep Archive, the lowest cost storage device. And as I've told you, we'll be looking at static website hosting in today's demo. The next one is API Gateway, Amazon API Gateway. This API Gateway is an AWS service that enables you to create, publish, maintain, monitor, and secure your own APIs at scale. So you can create robust, secure, and scalable APIs that can access AWS or other services as well. It supports both stateful and stateless APIs. The WebSocket are the stateful and the REST APIs are the stateless APIs. So you can use it either ways. And there are basically 2 kinds of developers who uses API Gateway. The one side is the API developers, the other side is app developers. Okay. Today we are going to play both the roles, how we will develop an API, how we'll use that API as a developer. So the developer, basically, he will create and deploy an API to enable the required functionality in the API Gateway. An API developer must be an IAM user in the AWS account that owns the API. As an API developer, you can create, manage API by using the API Gateway Console, CLI, SDK, or even using CloudFormation templates. It's similar to any other services, how you do the development on the AWS platform. And the app developer builds a functioning application to call the AWS services by invoking a WebSocket or REST API created by the API developer in the API gateway. So app developer is basically the customer of the API developer. That's how it works. Okay. So he need not even have an AWS account. If the API is exposed in some way, that it can be consumed by anybody. Okay. So now in our demo, what we're going to see today, API gateway together with AWS Lambda forms the app facing part of the AWS serverless infrastructure. This is going to be on the application side. The next service that we're going to see is Lambda. So what is Lambda? AWS Lambda is a compute service which will let you run the code without provisioning or managing the servers. It's as simple as assuming and relating or calling it as a function as a service. Okay, so you're going to create the code and you're going to upload it to Lambda service. And all that you have to do is just that. After that, where it will run, how it's going to run, it's all internal to the Amazon Web Services. Basically, Lambda is executed on a container. So what kind of container it has to spin up and execute it based on the language that you use to develop the Lambda function. So it is taken care internally. You don't have to worry about it. So there is zero administration with respect to this. AWS Lambda runs your code on a highly available compute infrastructure, and it performs all the administration of the compute resources, be it a provisioning server, taking care of the operating system, or scaling up the server, because whenever there is one invocation, only one instance of the function is given. Okay, one function is not shared by the multiple users. When the Lambda function is created, a particular instance is used only by one person. So each one gets a different invocation and its services. So you don't have to deal with the infrastructure in this case. And the language supported for development is Java, Node.js, Python, and C# from .NET Core. And you can have varied event sources. Event sources. So I was just telling that there were varied event sources from which this Lambda is being called. When we go to the console while we're doing, so I'll show you what are the event sources that is capable of invoking or triggering the Lambda functions. And you can use AWS Lambda either to run your code in response to events, that is event driven, such as changes to data in S3 bucket. For example, whenever you upload some file to an S3 bucket, trigger something. Or whenever data is entered into DynamoDB table, invoke this function. So as a response to an event, you can invoke this function. Or the second option is to run your code in response to HTTP request using Amazon API Gateway. Okay, so we are going to see the second option today. That is, we're going to invoke this Lambda function using API Gateway. Next service that we will be using is CloudWatch. I think so far with your courses, definitely would have used CloudWatch some way or the other. CloudWatch basically, it helps you to monitor any of the AWS services. You can have varied metrics, and the host level metrics are available by default, like your CPU utilization, disk utilization, etc. And if you need OS level metrics like RAM and other stuff, then you have to write custom metrics to capture those information. And the AWS documentation is available in detail, helping you how to write custom metrics, either using Python or Perl. So it's not that difficult to do it. And it has a pretty cool dashboards. You can have your own dashboards to see or watch a specific environment that you have specific set of resources that you want to watch. And you can define alarms, right? It allows you to set alarms that notify you when particular thresholds are hit. And we have events. The CloudWatch events helps you to respond to state changes in your AWS resources, right? So basically, this CloudWatch, in a nutshell, it sits under the management's repository, management tools section of the AWS services, and it can help you to monitor any AWS services, be it an Elastic Load Balancer or EBS volumes, EC2, ELB, S3, all that. Name it something, it can be covered under CloudWatch. There are two kinds of monitoring which is available with CloudWatch. One is the basic monitoring, which is like 5-minute interval monitoring, which is free of cost for almost all services. And if you really want advanced monitoring, which is like 1-minute interval recording, so that is a paid one. So if we wanted to know a little bit about the pricing before we start, so it's at a very, very high level for only these 4 services, this S3, API Gateway, CloudWatch, and Lambda. We're going to see at a very high level. Why we are seeing this is to see if I'm going to do this sample application in my personal AWS account, is it going to cost me? No, not at all. So it's as simple as that. I'm going to see, you pay for only what you use, and whatever we are going to try it out should be definitely covered within your free tier. So S3 data in is completely free. Whatever you're uploading is free. Whatever you're reading from S3 only is going to cost, and storage will also have minimal cost. There is detailed information is available in pricing for each of this, but for the purpose of this course, I think this information will be sufficient. And as far as API gateway is concerned, we spoke about 2 different APIs. One is REST API and WebSocket API. In REST API, you pay only for the API calls you receive, the amount of data transferred out. That is also like for better performance and faster API execution, you can also optionally provision a dedicated cache for each stage of your APIs. So this would incur additional charge that's going to speed up your execution. So, and the next one is WebSocket API. You pay only for the messages sent and received and the total number of connection in minutes. That is, you may send and receive messages up to 120 KB in size, and messages are metered in 32 KB increments. This is how it is calculated. Okay. And this WebSocket API also have some free connection minutes, 1 million messages sent or received, and 75,000 connection minutes for up to 12 months. So this is free as part of the free tier. And AWS Lambda, you're charged based on the number of requests for your functions. You create a function as a service and leave it in AWS Lambda, and you will be charged only for the number of requests you're going to make it, right? And the duration, the time it takes to execute your code. For example, if you wanted to see whether an EC2 instance is running, if you wanted to get the list of EC2 instances running, if you're writing a Lambda function for it, it's just going to run for a fraction of a seconds, right? So you don't have to maintain a dedicated server for that. So that use case, if you use Lambda, this pricing is done as a unit of 100 millisecond, right? If you recollect the message that we saw, the advantage of serverless is millisecond billing, that is sub-second billing, which means that the billing is calculated based on every 100 milliseconds. Okay, if at all your Lambda function execution have taken 180 minutes, then first 100 will be counted as 1 unit and the second, so 2 units kind of thing. So for every 100 second, it is metered to bill for you. Okay, so that's how to the lowest level it is built, and it's an advantage for us. So the last one is CloudWatch. As I've told you, it's free for basic monitoring and paid for detailed monitoring. I think whatever the testing that we're going to do, we will be using the free basic monitoring and take advantage of it. So that's about the pricing at a very, very high level. So let's start building a serverless application. Okay. So we'll see the network diagram here, and then I'll take you to the console. Okay, so this is the serverless web application that we're going to build. We will have a small Lambda function, which will just written a message saying, welcome to the serverless web application. Okay, so we will create one S3 bucket. From that S3 bucket, we're going to host static pages. That static pages is going to invoke the API gateway, which is configured, that is an API created. From the API, the call goes to the Lambda function, and that in turn returns to the API gateway and later through S3 back to the end user. So this is the cycle which we are going to see as part of our web application that we're going to develop today. And the first and foremost which we will be doing is creating the Lambda function. Okay, so there's going to be 3 steps. One is we're going to create a simple Lambda function and then create an API gateway and create an S3 bucket, make it as a static website. Once we do all these 3, we will be able to see the output as in this page. So this is the expected. This is what we are planning to do as part of the today's demo. Okay, so I have several slides here. So we're going for a building a serverless web app demo, use case 1. Okay, I'm going to walk you through 2 different use cases. Whatever we saw now in the network diagram is the first use case. I have several slides here on how to do it. Okay, this probably I'm going to share it. You can use it later. For now, instead of walking through those slides, let's go directly into the console. So for you to get a fair idea of what we are doing, I have a simple mind map which will tell you what exactly we are going to do, right? So when we start actually creating, so it will be kind of a revision so that you'll be able to relate better. So in our serverless web application, this first network diagram, we will create a simple Lambda function, create an API gateway and a static website. So what is that we're going to do as part of creating Lambda function? So you create the Lambda function and then configure it. When I'm creating, I'm going to create it from scratch. I have the code with me. So this is what is going to be my Lambda function name. I'm going to use the Python code and I'm going to create a role here called Lambda execution role based on this policy template. This is what we are going to do as part of creating. Once we create, and we will configure it. Okay, and add API gateway as a trigger. So we are going to create the Lambda function and configure it to have API gateway as a trigger. And then we are going to create get method in API gateway and deploy the API. Just remember these 2 things. We are going to create get method and deploy the API in the API gateway. That's it. Then in S3, we're going to create a bucket and make it as a static website and upload few files. So these are the 3 things at a high level. Okay, whenever we have doubt, we can come back and see what's happening here. I have opened the console already under AWS services. I'm straight away going to the Lambda. Before that, I want to see which region I have on EC2 instance, whether it is up and running. We'll move on to North Virginia region. I've gone to Lambda management console. I do not have any functions yet. When you have not created any Lambda function, it's going to look nice, clean and neat, right? So this AWS Lambda is going to let your code created here and you don't have to worry about thinking about servers. So all that we're going to do is create Lambda function from here, right? So I'm going to create a function. We're going to author from scratch. So I'm choosing these options. There are 2 different options. Use Blueprint, browse serverless app repository. So in case if you go to Blueprint, there are plenty of samples available. That's a huge list. You can choose from whatever you want and try. But for now, it has to be simple and it should be recreatable, right? So we are doing it from scratch. I'm going to have it as serverless web app demo as my function name. So I'm going to write Python 3.6 code role. So you might have read about creating roles when you're working on EC2 instances. So I'm going to create a role here to execute my Lambda function. Okay. So create new role from AWS policy templates. So what is the role name? It's a Lambda execution role. Okay, anything you name according to you. So I'm going to choose simple microservice permissions. And I'm going to create this function now. Role creation might take few minutes. The new role will be scoped to the current function only. So remember this, when we are going to the use case 2, the permission whatever has been granted to this will not be sufficient and it might error out in CloudWatch. Okay, once you create the function, this is how it's going to be. It has 2 tabs. One is configuration, the other one is monitoring. Configuration is where you have plenty of triggers. You remember we spoke about event sources for Lambda. So these are the different event sources that we have. This Lambda function, whatever you created now, can be triggered from API gateway, or it can be invoked by S3, or changes to the data in DynamoDB, or from code commit. Different events. So these are the event sources which are available. So now what we are going to do is we'll first edit the code. So this is the code, right? So I have a simple little code that we will be copying it. I'm having it open. So this is the basic Lambda function. We're going to just copy what we have and paste it. So this print statement is going to send something to your CloudWatch. And this is the response we will be sending to the web page. Remember, we are going to invoke this through the static website, which we will be hosting soon. Okay. So now we have copied and pasted this code. I'm going to save it. Once I've saved the code, I'm going down to see what are the other options available. You're going to use any environment variables. You can configure it. Similar to tagging in EC2 instances, you can create a tag here as well. I'm skipping this option now. The execution role, remember we just created Lambda execution role. That is what is assigned here. And description, I'm just saying it's a basic Lambda web page. I'm going to render a web page from this Lambda function. That's what I'm going to do. And the memory, what I'm going to allocate is like at present it's 120 MB. For the load that I'm going to execute, I don't need more than this. So I'm going to just leave it to 128 MB. See, here is the max that you can have, right? Remember, you'll be charged for those 100 millisecond rate and plus the memory that you're going to use. Okay, it shouldn't cost me more for what I'm doing. So let me see with 128 MB, and the rest all I'm going to leave it default. So use unreserved account concurrency. The maximum concurrency allowed is 1000. Okay, you can change it. You can reserve the concurrency. That's unreserved. You can reserve and keep how much you want to use it or not. Or in case if you see there are multiple users trying to attack your web page, or this Lambda function is getting pulled, right? See, whatever the web page that you're rendering now, if you have hosted an EC2 instance, you have to apply auto scaling and increase the number of those servers up and down based on the need. All that is not required now. In case if it is being overused or something, all that you have to do is just click throttle. This action will reset the concurrency for this particular serverless web app to demo. I mean, to 0. Okay, if you confirm, it will throttle. I'm not going to do anything here. I'm just going to leave it normal. And as it is stated, you can use this only in case of emergency. And I'm not going to use it. There's no dying emergency now. We're good. We're just starting to learn. So we've saved this. The next task I'm going to do is I'm going to add API gateway. If you see this configuration interface, based on the permissions that I've added, it has added CloudWatch logs by default, DynamoDB. I'm not going to use DynamoDB. Simply we chose the simple microservices. You remember we chose the simple microservices permission, that has added this DynamoDB. Okay, so that's how when you pick up something, it gets automatically added. I wanted to show you that. Now I want to choose the API gateway. So once you choose the API gateway, so it's asking whether you want to use the existing APIs. So I will go with Lambda microservice. Okay, I'm going to use the existing Lambda microservice API, and stage, I will use the prod stage. Okay, and security is obviously based on IAM. In AWS, nothing else is more secure than AWS IAM, right? So we've chosen that. This Lambda will add necessary permission for the API gateway to invoke the Lambda function for this trigger. So now I'm going to add this trigger to this Lambda function. Once we are done this, then we are going to create the get method there. So I've completed this. It's altogether a different UI. So I have to save this. So I'm going to save it. So now this is your endpoint, right? API gateway, it is created. Now let's click to see whether it is working. I'm going to paste it here to see whether it is working. It has returned the sample web page through Lambda function. Okay, this function is up. Now we're going back to the API gateway to configure it there. So let me open the API gateway. Here is the Lambda microservice that we got just created now. No wonder it worked. I think this get method, which I wanted to add now, was already existing. So it worked. What I'm going to do is, to show you a demo, I'm going to delete this method. And then now try whether this serverless application is working. It is still working, right? Okay. So all that we're going to do is, when we create this, by default, this any method gets created. We don't want this any method. Okay, we wanted to have get method to invoke this API to return the value. Okay, so this is how the cycle goes. When you request the method, it sends to the proxy, and via the proxy, it actually invokes this particular Lambda function and sends the response back to the client here. Okay, this is the actual cycle of method execution. Now we want a specific method, so we're going to delete this any method. I'm going to show you adding a fresh get method. So we will create a method which is get. You click this checkbox, it will create this. So we are going to choose the integration type as Lambda function, and I'm going to click this Lambda proxy integration. I'm a little confused. North Virginia is US East 1, right? Okay. So this is the Lambda function, what we created earlier, right? Serverless web app demo. Yes, it is available. So I'm going to save this. So you're about to give API gateway permission to invoke the Lambda function. Yes. Okay, now this is available. The cycle is in place. I'm going to the stages now. We already had the prod stage created. I'm going to this serverless and then get. So here is the URL, right? This is what I'm going to try and see it is working. In case if this is not working, what we have to do is, sometimes we get the missing token error. In case if we get the missing token error, all that we have to do is go and deploy the API. Once you create, go and deploy the API. So once we have created the method, we're going to deploy it. So while deploying, you choose the stage and select the description. Sample deployment to prod. Nothing goes as a test to prod, but we just given the prod name and then going by it. So this is the deployment we have created. Now we are getting the error, what the intended error, right? I thought we are not getting. Now since we are getting this error, so we have to redeploy the API again. That's what have helped me to go past this error in the past. So all that I'm going to do is redeploy this. Deployment. I'm going to deploy this. Okay, here is the URL. Still I'm getting the missing token error. Here is the API gateway URL. So I'll show you quickly from the screens we have here. So as a recap, so we've just created the Lambda function from scratch, right? And then we have assigned the policies, created the role as Lambda execution role, and we have configured by adding API gateway trigger. So this is a sample code, we are pasting it here, and then doing the basic configuration, nothing. We are just leaving them as is by default, just adding the description. Once you add the description, leave rest all to its default, and then configure the API gateway trigger. So it is configured.
Just one quick query here.
Yeah.
Can you just go to the previous screen?
Okay, this one?
Previous.
Yeah.
Yeah, so here the API name that we are mentioning has to be existed, or it gets created automatically new one.
Yeah.
So
which one you're asking?
The Lambda microservice that we are mentioning here, API, under API section.
Yeah.
So if it is mandatory to have this service existed in the in API gateway, or when we provide it over here, it creates a new one automatically.
It's a default service available. Lambda
Okay.
microservice is the default thing which is available. Okay. So once we create the trigger, add it, and then we deleted this any method and we created new method as get and configured as default. So after configuration, it's asking whether it's going to add the permissions. Okay, so we are at this stage. Now we are going to create the static website on S3. Okay.
Hi, Varun. I have one question. So
Yep.
when you create the API gateway and when you're clicking that link to see the function display, the web page being displayed,
Yeah.
is that your website URL, or that is what people would
People
use
shouldn't
to-
be using that. Okay. So we have created an API gateway link, which is invoking the Lambda function.
Okay.
That response is coming from our Lambda function.
Okay.
Okay. I'll show you the code for the Lambda function that we have created. So this is the code that is returning, right?
Mhm.
This is going to be the entire web page. We've
Okay.
just kept it simple. This is what it is coming.
Okay.
Okay, this is what it is returning. And we are creating an API gateway get method, which will invoke the Lambda function. So our API gateway is now a trigger to invoke the Lambda function. So these two links are in place out of our diagram. So two parts are done. Now we are going to have a static website, S3
Yes.
static website,
Mhm.
which is going to invoke this. So let's.
I just had another question around this. So
Yes,
basically,
please.
the API gateway, that serverless web application, is the link for Lambda, is it?
1 minute. Sorry. Yeah. Repeat it.
In the API gateway Lambda microservice,
Mm-hmm.
the link of serverless web application, that's actually triggering the Lambda function, is it?
API gateway is triggering the Lambda function.
Yeah. Can you go back to your slides? Basically, when you're
The diagram, right?
no, the trigger where you have configured the API gateway trigger.
Mm-hmm.
Yeah, how are you linking the API gateway's URL, the configuration?
Okay. API gateway URL is not linked to Lambda function. API gateway is configured to invoke this Lambda function. That API gateway URL will be embedded in my static website to invoke that. Okay. So the invocation is going to come from here. We have done these two pieces, right? We have done this backend Lambda function, which is going to return the web page. And we have created the little get API which is going to invoke the Lambda function. So these two bits are done. Now I have the API gateway link. I'm going to use this link in a static website, which will help me to invoke this Lambda function. Okay, are you getting this? Are you able to connect the dots now?
Yeah, thanks.
Okay.
Just one last question. So
Yes,
in
please.
in terms of REST architecture, API gateway is the one giving REST calls, whereas Lambda function kind of becomes the endpoint. Okay.
Yeah.
Thank you.
So now we are going to S3. Let me create a bucket with the name serverless web app demo. It's all smaller case, right? That bucket name exists. So I'm going to use same region, US East North Virginia. I'm just going to create this bucket. We'll grant whatever the permission required in a while. Now, all that I need to do is, did I create this bucket? What's happening? Oh, it's already created. Okay, now I've created this. So all that I want to do is, I wanted to make this a static website, right? So go to the properties, choose the bucket. So before I do that, to make it as a static website, this bucket and its objects should be publicly accessible, right? See, other buckets objects can be public, but whatever I created newly now, the buckets and objects are not yet public. I'm going to edit these settings, make sure all these things are deselected and click save so that it will be publicly accessible. The objects and bucket will be publicly accessible. That is our intent. Okay, now this is also made as objects can be public. Okay, that is done. So now I'm going to click this bucket and convert this as static website. Before that, I want to upload this. Okay, so before I upload it, I want to copy the API gateway link, right? I'm going to copy this API gateway link, edit my index.html page, right? I have an index.html page. I have two web pages. One is error.html, index.html. These are the two files which I'm going to upload to the static website. So I'm editing this index.html to place my API gateway here. Okay, I'm placing this API gateway URL and I've saved it. I'm going back to this S3 bucket. I'm going to upload these two files. So I'm going to upload these two files now. One in progress, one already success. So both have succeeded. So now these two files also should be public, right? Each of these things have a URL. So I'm going to make these files are also public because it's going to be a static website. I'm making them public. See here, I'm getting a little warning. Everyone will have access to one or all of the following files. Okay, I'm going to grant permissions. Fine. I want to make it open to the world for this simple example. So, okay. So I'm going to the properties, making this as a static website. So I'm going to, here is the endpoint for my static website. Endpoint is nothing but the URL to the static website. So I'm going to use this bucket to host a website. The index document is index.html. And the error will come from error.html. So once I have this, I want to save this. Let me copy that static website page. I'm going to try accessing this. Yes, I've got. So welcome to serverless architecture demo. I'm going to build a serverless web page using API gateway and AWS Lambda. So far, this is the content of the static web page, right? To proceed, click here. As per the index dot, sorry, I'm opening the wrong one. Here is the index page, right? When I click this, I'm going to invoke this function. This function is going to invoke the API gateway. And this API gateway is going to invoke my Lambda function. See, the final response is coming from Lambda function. to this API gateway and back to my web page. That's how we have designed. So I'm going to click here to see whether I'm getting this little message here, right? Everywhere I'm getting this error. So here is the actual URL. I want to paste this URL. So this is the actual output from the Lambda function through API gateway URL, right? This we have integrated with the web page. Now if I click here, you should be able to see that content here. So we got it. So that's how the flow works. So finally, this is the static web page hosted on a S3 static website. And from there, we are invoking the API gateway. That API gateway is invoking a Lambda function and returning this response to us. This flow is completed now, right? Okay, so I'll show you how it is captured in CloudWatch as well before we move forward. So now S3 is done. We're not going to disturb S3. Yeah.
Can you just let us know why you had put that URL in the index.html? What exactly it serves the purpose?
So there should be an invocation method, right? If you recollect what we spoke about API gateway, we are creating our own APIs, right?
Yeah.
This API acts as an interface to the backend to either pass values or return the values from the backend. Here our backend is a Lambda function. It can be a DynamoDB or Lambda function. Our backend is right now a Lambda function, which is just returning a little message.
Mm-hmm.
So we have created an API gateway get method. This get method is going to invoke the Lambda function and return its response. Okay.
Okay.
So now I am integrating that API with my static website to return the value from the Lambda function.
Okay, so when you access S3 index.html, you will get that index.html page, and when you click that button, it is actually invoking that API gateway, which will in turn go to the endpoint, which is the okay.
Yeah, thanks for asking that question because it would have clarified somebody else. Yeah, exactly. That's what I'm trying to do.
Thanks.
Okay, so now we have that in place, right? So what's next? We will look into the CloudWatch. What happened actually? Is there anything you can see in the CloudWatch? We will see before we move on to the use case 2. When I talk about use case 2, you will understand this even better because that's going to return some materialistic information. So under CloudWatch, if you go to the logs, so we have this AWS Lambda serverless web app demo, right? I didn't do anything. By default, it has created a log group in our Lambda function name, and it has recorded for our execution. Okay, so there were different executions here. Let's have a close look at this. The first one is request ID. The duration which Lambda function was executed for 29 milliseconds. The build duration is 100 milliseconds. Okay. If it has been executed for 1.29, we will be built for 200 milliseconds. So that's how the building is. So the memory size is 120 MB. Remember, I specifically showed you saying that I'm going to choose the least of the memory, and it has used only 55 MB of that 128 MB memory. Okay. If you aren't sure about how much memory is required, you choose something in between, execute it once and see if it is really on the lower side, change the memory accordingly so that you won't be billed too much. Okay, so this is how it gets captured. Now we will move on to the second use case. Okay, so we will come back to this CloudWatch for our subsequent error. So we will go to the second use case. Okay, so we have created the static website as well. We did all of that. Now we will see what we wanted to do in use case 2. So this one is a serverless web app to turn off the EC2 instance. So basically, why you have to turn off the EC2 instance, right? It's your EC2 instance is not like a VMware running in your data center, right? Any minute it is running, it's going to cost you, right? Imagine a geographically distributed development center. For example, you have a development center in India, North America, Germany, all that. For example, in India, probably on an average, people would work between 9:30, 10, or max to 8, right? 8 o'clock, most of your developers would leave. And if this is a development instances or environment which is running after 8 p.m., you can do an auto off EC2 instances. Any EC2 instances, if you have created and added a tag as auto off equal to yes, that needs to be turned off at 8 p.m. IST, or if it is a Germany, or if it is North America, whatever it is, PST, EST, as you schedule it, you can turn it off. For that, you need not have a separate EC2 instance, have a scheduler or function running on it. You can write a little Lambda function in the language of your choice, be it a Python, Node.js, Java, whatever it is. Create it and schedule it and leave it. It will turn off. Or if you don't want to schedule, in this example, what we are going to see is I am going to have a Lambda function which will look for the EC2 instance tagged as auto off equal to S and then turn it off. Okay, that's what the Lambda function is going to do. And in my static website, I'm going to invoke the API gateway. This API gateway is in turn going to invoke the Lambda function. The Lambda function is going to read the EC2 instances that are running and are tagged with auto off equal to, and then shut down those instances, put them in the CloudWatch logs as well, what instances it is turning off, and also send us a response to my web page as well. Okay, this is what we're going to do as part of this. Remember, we all familiar with the static website. From there, the API gateway is linked. I'm not going to touch the static website or the API gateway link. All that I'm going to do is I'm going to edit the Lambda function. I have to make sure I have EC2 instances, one or more EC2 instances with this tag value, right? Now, let me go on to the Lambda function. So once we execute, this is the output I'm going to expect, okay? This is going to return the running EC2 instances and the details about the EC2 instances, okay? So this is how my output is going to be here. So I'm going back to the AWS console, going back to the Lambda screen. I'm not going to waste time in creating new functions. So I have the pre-written Lambda function to stop the EC2 instances. I'm going to copy paste the code for this. This is available in GitHub. I can share it with you if you want to create it. So all that you will do is you will paste it. Okay. So if you want to see, it will look for the EC2 instances that are running with a tag auto off equal to yes, and it's in a state running, right? Filter them, get those EC2 instances. And if the instances are running, gonna shut down, right? This is what we are stopping, the EC2 instances that are running with specific tag value. Now this is created, I'm going to save it, right?
Okay, so when this Lambda will be invoked?
Pardon?
When this Lambda will be invoked?
When this Lambda will be invoked, whenever I'm clicking the, 1 minute, let me move this. So whenever I click this button, click here, right?
Okay.
So that's where,
So that will be our triggering point.
yeah. Once again, I'll show you the index.html. So in this index.html, you remember I put the API gateway URL?
Yes.
This API is the triggering point to your Lambda function. Okay. So my web page index.html on my static website is going to call this API gateway. API gateway in turn is going to invoke this Lambda function. That's the flow. Our Lambda function is the backend. The index.html is the front end. This API gateway is the trigger, which is going to trigger the Lambda function. So that's the flow. Okay, so now I have this web page. All that I did is went and checked this, changed the Lambda function. I didn't change anything else. Now I'm going to run this to see what it says. Okay. Nothing happened. Is there any EC2 instance running? So let's quickly go and check whether there is any EC2 instance running. And this EC2 instance should have auto of tag. So it's not running. I'm going to start this. And also let me check whether I have a tag. Yes, I have added tag auto of equal to yes. Okay. Now once this turns to a running state, I should be able to read it. It should be able to detect the instance in a running state and shut it down. Okay. Let me keep the IAM as well ready. So I've kept the IAM open, EC2 instance. Let me see whether it is in a running state. Yes, it's in a running state. So CloudWatch logs. So this has created another instance, right? We said nothing was working. Okay. So now we have created a EC2 instance. That is, we have started the EC2 instance. Now we're going to run it again. It should actually stop, right? Let's see whether it is stopping or not. It didn't do anything still, right? Though I have an EC2 instance running, it's not attempting to stop. We will see the CloudWatch for the other error. What has happened? Did it actually run or not? So now when you go to the CloudWatch, see here is the error. So twice I ran and here is the error. An error occurred, unauthorized operation when calling describe instance. You are not authorized to perform this operation. So why this error is happening? In Lambda function, we are trying to get the list of the running EC2 instance and stop, right? So we do not have permission to get the list of EC2 instance. That's the error. You remember we created a role called Lambda execution role and we gave some limited permission to that role, but we didn't add anything about EC2 instance, right? So now we are going to add EC2 instance admin policy so that we'll be able to shut down the EC2 instance as well. Okay. EC2 full access. So I'm going to add this. As soon as I add this policy, now I'll be able to run this web page and shut down the EC2 instance which is running. Okay, I'm going to click this. It has listed here. It has got hold of the only EC2 instance I had and trigger the stop. Yeah, it is stopping state, right? Eventually it will be stopped. It is still stopping. That's fine. As long as it has triggered to stop, we are good. We'll go and review the CloudWatch logs. This is the CloudWatch log. First 2 times when we had clicked, it has actually failed. Now the third instance is it has succeeded. It is printing the EC2 instance here and the details about the EC2 instance. It has stopped it. It has taken 546 milliseconds to read the EC2 instances and stop it. Okay, so it has built for 600 milliseconds. And for that also the maximum memory used was 80 MB. So we are good with this 128 memory. Irrespective of the Lambda function have failed or succeeded, each execution have costed something. Okay, so keep this in mind. Every execution, though, like you won't be billed. I'm just telling you for the knowledge purpose. This is how the billing happens. Okay. So this is the actual demo that we wanted to do. Now we go back to this slide. So anything now you got the flow.
Yes, Bhuvaneshwari. So you copy the code is a Python written program which you have copied the code from their terminal. Yeah, that one.
It's a Python code. It's a Python code.
Written. Okay.
Yeah.
Hey,
That's a Python with Boto.
Boto. Okay. Fine.
All that we are doing is applying a filter by the tag auto off and its value to be S. Okay, and the instance state should be running. If these two conditions satisfies, fetch those EC2 instances and put it under this array, right? In the list.
Okay.
So then you take them, just print for your reference to see what instances. All these print statements is putting the information into your CloudWatch. It's basically logging to your CloudWatch. Okay. And then if that is greater than 0, I'm like issuing this stop command to shut down the set of EC2 instances, not a single instance. Even if you have a bunch of EC2 instances, all that will be shut down in a single command. And the list of instances that were shut down is again sent, and the string is concatenated here to send us a response information. This is the response information. We send it back to the index.html. Okay, that's how it fetches an index.html and it replaces here. Okay, it gets and replaced in this span tag. That's how the information is fetched and displayed here. You can do it in any way. You can just put it in the CloudWatch, or you can even integrate with ACS and send an email notification to the stakeholders saying these are the list of EC2 instances that have been brought on. Basically, the idea was to show how the flow goes from your static website to the API gateway to the backend, which we call as Lambda function. So that was the idea.
Hi, could you please show the API gateway configuration also?
Okay. So you want me to show the configuration on the Lambda side, or?
The API gateway, like configuring the API gateway with Lambda.
Okay. So I had added this API gateway here already, right? I can create one more function and then do it for you. I'm going to use the existing role because we already created and we gave all the permission that is required. So I'm giving the Lambda execution role. I'm creating the function. Since this had all the access for EC2 also, so I'm getting so many things here in this IDE. I'm going to add API gateway as a trigger. This is the configuration that you were looking for. So I'm adding this trigger. Okay, prior to adding the trigger, we actually pasted the code that was required for this, right? So let me put the code for the basic Lambda function, just to be sure, to tell you what we have been doing. Okay, I'm saving this information. Then I'm going to add API gateway trigger. I'm going to click this. Okay, so in this, we are choosing the Lambda microservice. Okay, this I didn't create it, it's a pre-existing one. We are choosing it. This deployment stage, it's an already existing one. So I'm choosing this deployment stage. In security, it's IAM. We're choosing this. So once you do that, as soon as you save, this API gateway URL, all that will be created.
So, so one question here, for deployment stage, always is a prod. It nothing have a pre-prod stage. I mean, like a kind of a.
No, you can create anything. It was just lying there in my API gateway. It is coming. Okay, so you can create. We'll go back and create something else. It is the stage prod. You can create a stage.
Oh, okay, fine. Yeah, thank you.
Pre-prod. Okay. And schedule deployment. If you want a specific time, you can do it. And the other option is, in this second use case, we got this. So basically, this is the steps in nutshell, which we did it. For you to recap, just copy the code from stop running instance.py to replace the existing Lambda function. I've added EC2 full access to the Lambda execution role, which we created earlier, because otherwise it was erroring out in CloudWatch saying that it do not have sufficient permission to do so. And then I made sure that we have some EC2 instances with auto off with a value S. Please make it a point that it's case sensitive. If you have given a value with capital YES, it doesn't work. So pay attention to it. And then we just went ahead launch the static website URL to trust our Lambda function, which is going to look for the running EC2 instances and then turn them off. Okay. So the debugging is, we saw that the missing authentication token error, if you deploy the API again, it vanishes. So this comes majority of the time when you create the API and attempt to deploy. And most of our debugging is like Lambda function. The CloudWatch is the best thing, and that's the only way you get the errors. So go pay attention to your CloudWatch logs. If you wanted to enable more debugging, add debugging statements there so that we can catch them earlier and get it fixed. Okay. So, and yeah, we already saw this. This is the other option, right? We have been seeing only through S3 route static website URL. And if you have to do with the actual domain name, you can include Route 53 and route it via Route 53. Okay, once you have the Route 53 in place, the user request goes to the domain name, probably serverlessdemo.com, and that serverlessdemo.com in your Route 53 records, it can be configured to go to your S3 bucket, the static website, and then the regular route, API gateway, Lambda function, EC2 instance, and back to the user, right? So you can improvise. So every stage you can add little things to see. And the other thing is you can put in SES here, the Lambda function, instead of just printing it along with, or instead of just printing it onto the website, you can also send an email or notification by putting SES. You can try doing that. It's not that difficult. Probably if you want to try, pull out the code that I have in this GitHub repository and then start adding SES to see if it is working. So you can try out different things. This is the simple web application I want to walk you through. We can see about the other monitoring things. If you go to the Lambda function here, we have two different things, right? One is configuration, the other one is monitoring. So if you go to the monitoring side, it'll tell you how many times you have invoked this function, all that. Okay, this is web app demo 2, which I created. I'm going to delete it because I will not be using this function. I just created. Just creating a function, keeping it there is not going to bill us in any way, but just as a cleanup measure, I'm deleting it. So let me go back to our original function, serverless web app demo. No idea why it's taking all of a sudden long time. CloudWatch is quick. Only Lambda got angry, I think. Okay, now it should come. Okay, so this is a function. We have this monitoring, right? So we can see CloudWatch metrics at a glance here. How many times it has been invoked. So between these times, I've invoked twice, right? And how long it ran. What is the duration, max duration? See, this ran around 300 milliseconds, and then this one, and again 690. That was the max milliseconds it ran. Error, yeah, I got some errors as well, right? I haven't throttled, so there's nothing here. So you have a nice dashboard for looking at your CloudWatch metrics here. So you can directly click this link to go to view the logs in your CloudWatch instead of directly going to the CloudWatch. This also takes to you to the specific log stream itself. Okay, that's a shortcut from there. Okay, now we saw that. Let me clean up, okay? I don't want to just show how to create it. I'll also show you how to delete it. So, okay, while creating, we went from this direction, right? We'll go backward now. We create a Lambda function, API gateway, and S3. So let's clean it up from the S3 bucket. So I don't want to leave all these things, whether it's going to bill it or not. Okay, let's clean it up. I'm going to the S3 bucket now. So this is running. It should stop working in some time, right? Okay. So this is the bucket which we have created. So I'm going to delete this bucket. So when I'm clicking to delete, it's going to ask me Are you sure I'm going to delete it? So I have to type the bucket name to delete it. So I'm going to delete the bucket. So operation success. So it has deleted the bucket. The next one, we will go to the API gateway and Lambda function. We'll delete both of them. You remember we created the serverless demo web app and added the trigger. Whenever we add a trigger, it actually adds an entry into the API gateway. When we remove the Lambda function there, it doesn't do a cleanup here. So let's make sure to clean that one. So I'm going to delete this resource.
Just one question for the API gateway.
Yeah.
So here we have triggered Lambda using the gateway. Can we trigger any other backend? So you referred Lambda as a backend, right? Can we trigger something like ECS, Fargate, or something like anything, all those other services?
See, API gateway can be used pretty much with anything, right? So I do not have a demo to show you what all it can invade.
Okay.
But you can play it around with plenty of other services as well.
Okay. So where do I configure that if I have to trigger that?
Which one?
If I have to trigger an EC2 instance or a code on a EC2 instance.
Okay.
How do I trigger that?
See, this one, when you go to the API gateway, right? You can integrate. I do not have a demo. I think we can take this question offline.
Okay, no problem.
If you're going about EC2 instance, then we will not be able to clean up other things within the session schedule. So I thought, let me finish this up. Pretty much you can integrate this with Lambda, Kinesis, DynamoDB, and other stuffs.
Okay. It would be helpful if you can even send a document to us. We have a WhatsApp group, right? So if you can just ask Kanchan to forward a document.
Okay, what information you're looking for, let me know. I can pass it on. So how do you
trigger any other managed service? Yeah.
Okay. How the API gateway can be made to work with other services, right?
Yeah.
I'll share some information. Okay, we'll do that. For now, we'll go ahead and clean. Sure. Thank you so much. Yeah. So I'm going to delete this resource as well. Okay, I'm going to delete the stage as well, man. Every time this comes up, right? By default, I don't want to go with a prod stage all the time. So next time I would create a new stage. If it is not there, obviously it'll ask me to create a new stage. So I have deleted. I've cleaned up everything, right? Resources and stages. So I'm good on the API gateway side. So we're going back to our Lambda function. Now, if we open the serverless web app demo function, we should not be able to see the trigger integration because we have deleted the trigger. Let's see what's showing. I have no idea why Lambda function doesn't come up. Okay, still this trigger is there, but the configurations are lost. Okay. So now I don't want this function as well. So I'm going to delete this function to serverless web app demo. So now we have deleted the Lambda function, S3, API gateway. What else is remaining? There are two more things we can clean up. Any guess what else is remaining?
IAM policies. It must have created some policies.
Yeah, we created one policy, right? Yes. One more if we wanted to clean sweep.
EC2 instance as well.
EC2 instance that we didn't create now. That is shut down, so I am okay with that. As long as it doesn't bill me, I'm good. So I'm deleting this Lambda execution role which we created. This got created 30 minutes ago, right? 32 minutes ago. Okay. Last activity was 32 minutes ago. Okay. There's one more that was not created by us, but it will be leaving a junk there. CloudWatch, right? Since we have destroyed all the applications, right? Would it make sense to leave a CloudWatch log group there? We deleted the Lambda function, but this log have not gone. We don't need them anymore, right? So I'm going to clean up that as well. This was last bit. So I'm going to delete it. You can also export it in case if you want it. So I don't need them. I can create them quickly because our demo was very straightforward. We can get them quickly. So clean sweep. So all that is gone, right? So we are good. So we have created everything and we have deleted whatever is not needed as part of the demo.
All right. So for the people who have not heard of containers, what it means is containers are simplified versions of virtual machines. The main difference between a container and a virtual machine is that in a virtual machine, you're virtualizing the entire system. You're virtualizing the OS, the underlying hardware. But in terms of in a container, right, the hardware and the OS is shared. It's only your application which is isolated out. Satyadeep says he's heard it as a buzzword along with Dockers, but not familiar. So Docker is a company. So I have written a book on containers and how to get started with containers called Practical Docker with Python. Slight plug to read it and buy it. But basically containers are, like I said, it's a simplified version of virtual machines. Containers are small, lightweight, and they can be launched faster than VMs. Why? Because with a virtual machine, you need to virtualize the entire system from start, including the BIOS, the hardware, the processor, the hard disk, etc. But in a container, you are sharing the host OS's kernel, and the only thing that you need that gets added separately is your application. So it's basically an isolation mechanism. So in other words, container provides you a way to package your applications, code, and dependencies into a single object. Docker is the company which kickstarted the container revolution because they came up with a product called Docker. Before Docker, we had Linux containers, and we had Solaris jails, for example. But trying to understand and trying to make use of Linux containers was pretty difficult. What Docker did was they wrapped whatever options, whatever features that were available as part of the Linux kernel into a very nice CLI, and you can basically run an application however you want. Suja, to answer your question, container runs directly on a host OS? Yes, it does. But because of the isolation mechanism, it looks like it is running on a separate OS. Okay, the host kernel is the same, the host OS is the same, but for all practical purposes, it looks like it's different. Okay, Kubernetes is, we'll get to probably Kubernetes towards the later part of the course, but Kubernetes is an orchestrator. But since you're asking about what Kubernetes is, what does an orchestrator do? Let's say that you have a container running with one application. Okay, so you have a Docker image of your, let's take the e-commerce example. You have a Docker image of your e-commerce application, and it is running on one virtual machine as one container. Okay, so now what happens when the container dies, right? Your application goes dead, and your server cannot, your consumers cannot use your service. Let's take the other example. You have a VM, you have an e-commerce application. You are running a flash sale, for example. Now, all of a sudden, the number of requests has increased. You need to increase the number of containers running. So how do you do this? That is where orchestrators such as Kubernetes comes in. What they do is you say that I want X number of containers to be running, and the orchestrator handles that, right? So if there's less than X number of containers running, Kubernetes or any orchestrator will constantly monitor that, and they will bring up more number of containers to keep up with that. They can, orchestrators can do one step ahead if they see that none. So now what happens is you have your container running on one host. Now let's say that this host has hit the number of virtual machine and has hit the number of containers that can be run. Orchestrators such as Kubernetes can also bring up a new host so that more containers can be spawned. Running Kubernetes in production can be can be a bit of a complicated affair, but the rewards based on your application and your use case, it can be worth it. So we'll not have to worry about it now. We can look at it later. So containers are stateless in terms that Sushant made a very good point that containers are stateless. What does that mean? It means that basically if your container dies, any data which is there in the container, it gets killed, right? So if you would have heard saying that containers are bad for databases or stateful data. Why? Because if the container dies, all the data along with the container is dead. But there are ways of working around it. You have options for mounting a volume where you can save the data in a separate hard disk, for example, or on or somewhere else. But that's a question for later. So Docker Swarm is also an orchestrator, much like Kubernetes. Swarm is what Docker tried to do for managing and for running containers, but they were not fast enough to the market. And by the time Kubernetes had come, and what the features that Kubernetes offers are a lot more as compared to Docker, to Swarm. Having said that, for if your application is not very complex and you don't need a whole lot of orchestration capabilities, it might be easier just to use Swarm as compared to Kubernetes, because when you're talking about Kubernetes, you're talking about a data store for Kubernetes, which is etcd. You need to worry about the master node for Kubernetes. It's a whole different game altogether. Okay. Is container a replacement for VM? It can be. There are some cases where, for example, if you're running Docker in Windows or a Mac, you're still running a VM. Why is that? Because Docker uses features of Linux kernel, such as cgroups, seccomp, and namespaces. And all of these are native to the Linux kernel. And these are not available on Mac and on Windows because they use a different kernel altogether. So what Docker does for Mac and for Windows is they bring up a very thin, lightweight VM, and they run the containers on the VM instead. So if you're talking plainly, purely from a Linux point of view, is container replacement for a VM? I mean, in my team, for example, at my workplace, we have excuse me, we have stopped using VMs altogether. It's all Docker everywhere. It's all containers everywhere. I don't think we have any use case for a VM whatsoever. Okay. So Sushant, VM uses hypervisor containers does not. That's not entirely true. Like I said, when it comes to a Mac or Windows, you still need a hypervisor because you still need that VM to be running. Because Windows and Mac, they don't offer the Linux kernel features. But more or less, you are right. What makes them lightweight is that with containers, you don't need to virtualize the entire machine. You don't have to virtualize the entire OS. So now that you know what containers and what container is, how does this tie into serverless? So with serverless, what you need is a very quick way, a very rapid way of starting your workload. That is why containers go very well and hand in hand with serverless. So what happens is that when your request comes, I just showed you this request. So when you say 10 USD in 695 INR, so what happens is a request goes to the API gateway. API gateway then forwards it to Lambda. So what Lambda will do is it will, when we are defining a Lambda, we have said that this is our code that we are using. Let me just show it to you. So you see, this is my code. I have 1, 2, 3 files. You'll have 1, 2, 3 files, which is basically, these are part of the Lambda. So what will happen is when the request goes there, AWS will bundle up these and it will it will launch it, which will bring up a container, and it will copy that application code to that container. Okay. And because containers are quite fast and rapid, you get a very good response in completing their code. Okay. We'll have lab exercises, but I'm just giving you these as an example of what is possible with serverless and containers. So don't worry about thinking that this is very complicated or we need to worry about this. You'll get this over time. It's quite easy. You don't have to worry a lot about it. So what are the use cases for serverless? So primarily, these are the most common use cases: API-driven workloads, scheduled job automation, event-driven model. API-driven workloads, if you have multiple endpoints, instead of having an entire application running on one server and running the application on a VM, what you can do is you can break up each of the workload for that API into a function. So what happens is each endpoint can have a function, and when you call that API endpoint, the function is invoked. So the good thing is that you can scale independently for each endpoint. What does that mean? Let's say that you have a /reports endpoint, which will generate a report. Report generation is can be quite intensive because of all the data gathering that is required, and then to generate the PDF or whatever it is. And as compared to, say, saving a phone number for a customer, that's not a very intensive workload. So, instead of running, say, 10 instances of the application for this endpoint, what you can do is you can break it up and say that I will have one function for saving the phone number. I'll have one function for generating the report. And because the number of requests coming to report generation will be a lot more, your application will be able to scale independently and will be a lot faster as compared to having an entire monolith. Okay, scheduled job automation. This is one of my favorite use cases because we've all had this case where we need to run something once a day, once a week, once a month, and we are running an entire server for it, and nothing else is running. For example, your daily backup jobs, or your weekly backup jobs, or your hourly backup jobs. We cannot run the backup jobs on the main server itself because it will cause performance degradation on the main application, right? So instead of that, we'll bring up a new server and we'll run our report there, our backup there. But now we have one server running all the time just for one purpose, which is backup. And that backup is not even used that often. It's not run that often. But we need to have a backup, right? It's quite important because suppose your data goes, you lose your data. If you don't have a backup, it's gone forever. And it can be the difference between keeping a company running and shutting down a company. So you cannot skimp on that. So, instead of running a server for this, what you do is you define a Lambda, or you define a function, you define a serverless model for that. Define a trigger for that function so that every day, every hour, every month, whatever might be your trigger, run the function. That function will invoke, and whether it is a cold start or warm start, it doesn't matter. Whether it runs fast or slow, it doesn't matter, because for us the objective of backup is the backup is completed successfully. It doesn't matter a whole lot. It does matter to some extent, but it doesn't matter a whole lot whether or not the backup takes 5 minutes or 6 minutes, right? So we just needed to get it done. And the third one is my favorite, another favorite of mine, event-driven model, trigger function based on events. What does that mean? I just give you an example of that, right? The currency converter bot is a perfect example of event-driven model. I said 10 USD in 695. That is an event. The message goes, that is an event. That triggers a function. that runs the function and it comes back, right? Now you can have more complicated use cases. You can say that I use in this currency converter bot, I can make it into a general chatbot, and I can say that if the question is currency conversion, run the currency converter function. If it is about general questions, give me a general question, right? So that is an example for event-driven use cases. If you use IFTTT or Zapier, that's another example for event-driven model. Let's say that you want to send an email, or you want to send an email, or you want to send a message to your spouse or to your family when you reach a specific location, right? So that's another example for event-driven model. So you can model a lot of those using functions brilliantly. Practical example of API-driven workload. Have you heard of, it'll come to the use case, customer testimonials, but since you're asking here, have you heard of Shabrimala? So Shabrimala is a temple in Kerala. So around about this time, the demand for it is huge because they are open during this time. A lot of people visit Shabrimala, and for that they need to get a virtual ticket. So what the developers of the portal did was that they were earlier running the entire application on EC2, which is basically the cloud compute model. And they had a lot of trouble scaling because they couldn't shut down the server completely, because occasionally they'll get 1 or 2 requests. But during the Shabrimala season, which is around about this time, they would get a whole lot of requests, and they were not able to cope up. So what they did was they split up the entire application into different functions, and each API would call a function. For example, when you say generate ticket, it will call the generate ticket model, the generate ticket function. And that helped them decrease the cost quite significantly and improve the performance. You look at it in a bit. But does anyone else have any other idea? Do you think you've been using serverless as a consumer? I just gave an example of using a chatbot, but do you think you would have used any other serverless model as a consumer? If you think you've been using, can you give an example? IRCTC is not really an example, but WhatsApp, LinkedIn, no, they're still not using serverless completely. A Cloud Guru is running completely serverless, yes. Vishal has a very good example of Alexa, which was my second point. But the first one is, have you been to the e-commerce portals, right? And you'd have seen the images of the different items that are on sale. That is a good use case of a serverless model that you've been using without knowing. Most of the e-commerce portals have been using Amazon S3, which is a managed storage service. So when you visit the e-commerce portal and check out an item, you'll see a picture of that. The picture is downloaded from S3, and S3 transparently downloads the images, right? So this goes to show that there is more to serverless than just functions. So there's a lot of difference between. There's not a whole lot of difference between serverless and functions as a service, or FaaS, as you would have heard of it, or FaaS. FaaS is an example of a serverless model. So it's like this: you have a serverless model, and you have different use cases of a serverless model. One of this is a managed service, for example, like S3. With S3, you don't have to worry about. You don't have to say that I need X number of images to be served. You just upload and you just put your images. You can, and S3 and Amazon will transparently take care of scaling that, providing the images as fast as possible. If you have not used S3, you will use S3 as part of your course, so don't worry about it. And the next example of serverless would be as Vishal said, Alexa. How many of you have used Alexa or Google Home? So if you use Alexa, you have a trigger word saying Alexa, and then you have the second bit, which is the context, right? So Alexa is recognized by your Echo device which is on the hardware. The other part, which is, let's say that you want to know, you've developed a function which says how many visitors are there on Great Learning. So you say, Alexa, how many visitors are there on Great Learning? So what happens is when you say Alexa, the Echo Dot device recognizes it and it sets this part, okay, to the Lambda. So when you package that skill, you would have said that for this voice invocation, you need to run this Lambda function. So this is an example for serverless. So what serverless options do you have? So you have, so the first three here are managed serverless providers: Azure Functions, AWS Lambda, GCP Cloud Functions. So if you want to provide functions as a service, or if you want to provide serverless for your internal customers or your internal users, there are two packages. One is Apache OpenWhisk, the other one is FN Project. So these are used for, so you can install these on your local systems, and they will handle serverless model for you. One of the projects that I work on, which is Adobe IO Runtime, we use Apache OpenWhisk. So with IO Runtime, what you can say that you can say the moment you've uploaded a photo to Creative Cloud, you can run a function which automatically tags it and things like that. So you can we use Apache OpenWhisk for that. So who else is using serverless, right? So who else is using serverless? ABP is basically, you've heard of the ABP News Network. It's one of India's largest TV channels for news. So they have news in Hindi, Marathi, Bengali, Punjabi, Gujarati. So they use Lambda to update the content feeds. So whatever feeds that you're seeing on your TV, you would have seen those news stickers, for example. So what you can do is they use that. They also update the feed from their self to the mobile user as a Lambda function. So there's one more case where you don't need a server to update to send something to the users. Saturn System is what I was telling you about the Sabrimala Virtual Queue portal. So they've reduced the cost for running their systems by 30%, and this is after having a 42% increase in the number of users. They said that the number of bookings for the Sabrimala users reaches about 3,000 requests per minute during season, and off season it goes to almost zero. And because of this, they moved initially from their on-premise version to EC2. And once Lambda came into general public, they went to that. The third use case of someone else who's using serverless is me. So I had a couple of EC2 instances which which were running up unwanted data. So to give an example, we have a test environment. We run our end-to-end tests every 10 minutes. And what we do is we run the tests, we collect the data, we confirm that the tests have been run properly, and we retain the data for 7 days, just in case we need to refer back to it. Earlier, now I used to have an EC2 instance running, and I would run a cron job on it. It was a small instance, but still, it was nevertheless still a waste of resources. I had a cron job running on it, and every 7 days, every 15 days, the cron job would run, it would clean up. So I got rid of the server and I replaced it with a Lambda. So every 15 days, the triggers are the same. Every trigger day, every 15 days, it will clean up the data. And yeah, that's at least one server gone. So the other advantage of not running is that you don't have to worry about maintaining it, keeping it up to date in terms of patches, in terms of update those SSH keys and whatnot, right? The other use case was that I replaced a MySQL database with Amazon's Aurora serverless. You actually heard it right. Amazon has a serverless database model. The way it goes is that Aurora is basically Amazon's version of MySQL. When you have a request coming in, you have the database running, and once the requests are no longer there, Amazon will shut down the database. Your data still remains as is. There is no data loss, but the instances are not running. This is again tied to the same use case where we had tests running every 10 minutes. The number of write for that database in that during 1 hour would probably be like 5 or 6, and maybe reads would be like 1 or 2. It was as skewed as that, it was as heavy. And running an RDS for this, it just didn't make any sense, right? So what I did was basically tear down the RDS, replace with Aurora serverless. So when the request comes in, the Aurora instance, it spins up, it writes the database, it goes to standby, it goes to sleep. Aurora is present on some server. Yes, it goes back to my original slide where I said serverless does not mean no servers. It means that there is some server running, but you don't have to worry about maintaining that, right? It's somebody else's headache. I've come to a conclusion. If you have any other questions, I'm happy to take them. And let me just give you an example in the meanwhile serverless means someone else is taking care of running in server. Is this not the same default cloud or managed services? No, like I said, serverless, there are very specific requirements in terms that, let me go back here. I will explain about Zappa in a bit. So for serverless, it's not just a managed service. There are these 4 checkboxes that you need. One is no server management. One is scaling on demand. One is true pay-per-use. Other one is high availability. With managed service, you don't necessarily get high availability out of the box. For example, if you're using Amazon's managed database service, which is RDS, there is no server management, true. Somebody else is taking care of it, true. But there is no scaling on demand. You need to explicitly, excuse me, you need to explicitly say that this is the instance size that I want. It is not a true pay-per-use because you're paying it for hourly basis, not per number of times the database or a function has been in use. And high availability is, again, not out of the box. You need to work your way towards implementing high availability and fault tolerance. You can set serverless, you can set auto scale, yes, but again, you don't get, if you set auto scale, then you don't get server management, right? Pay-per-use managed services is not the same pay-per-use. If you set the options, you get all of this. Sure, you get all of this, but if you get if you're managing high availability, then you have to do it. For example, RDS. I'm going back to Amazon Managed Database Service. If your master database goes down, Amazon does not automatically switch to the failover option. You need to do it by yourself. If you set managed services to a specific autopilot mode, is it equaling serverless? Not necessarily. You can set up a managed service which has no server management, which has scaling on demand, which has true pay-per-use. I still argue that you can't get true pay-per-use because you're paying per hour, not per actual invocation. Right? So and high availability, again, you have to work your way towards it, right? What do I mean by true pay-per-use? Let's say that you have a managed service that you're paying, say, $10 an hour, or you're saying 500 rupees per hour. Okay. You have a serverless model where you're paying, say, 5 rupees per invocation. So in 24 hours, you've been running your managed service, so you're paid 24 into 50. All right, so that's, sorry, 24 into 500 per hour. So that's 12,000 per year that you paid per hour. But in serverless model, you paid your application as your function is run, say 50 times, and you paid 5 rupees for it. So you're paying only 250 rupees for that. I hope you understand what to pay-per-use these things. So Soja, yes, paper transaction means pay-per-use. So you can say that it's basically paper transaction. What are the features API Gateway provides or uses other than request routing? It's a bit of a advanced topic, but I'll give you a demo. I'll show you what you can do in a bit. So people, for those who are asking what is Zappa, Zappa is basically a serverless wrapper. So with Zappa, Zappa automates bringing up a Lambda function, an API gateway, etc., etc. Okay. Okay, let me take a few questions right now. So pay-per-use means paper instance session, click on transactions. That will depend on what the cloud provider says in terms of, excuse me, in terms of AWS. In terms of Lambda, they very specifically say that it is the number of times you're calling a function. Okay, plus the number of hours or it's been, the function has been running. So it's not necessarily number of times you're calling a function. It's the number of hours that the function has been running. Does a container act as a wrapper around an application, irrespective of environment or type of environment it is developed? It does, because when you are into specific, in a general case, it can. Basically, you can have a custom purpose container which can run any application. In terms of Lambda, you are saying that my application will be a Python-based application. So Lambda will prepare a Python-based container ready. Okay. In case of services where we are having high utilization and number of invocations, can it be more cost efficient to use? No, you are right. If you're having a very high, so serverless, so serverless is not for all the use cases. There are very specific use cases for serverless. It does not mean that serverless is there, it is cheap. So you put your long running task or your very heavily utilized tasks, very heavy utilized VMs and put serverless. You need to define, you need to look into it, and you need to see whether serverless is going to be a good enough use case for that. But the beauty of serverless and cloud providers is that you have all the options, right? You have an option of running a managed service. You have the option of running it by yourself. You have the option of using serverless. You can do a cost estimation and analysis, and you can see which works out best for you, right? As compared to earlier model where you were running it on a DC, or where you had a VPS, or where you just had a VM, you didn't have these options at all. So serverless is definitely not for everyone or for all the use cases, but for the use cases where serverless is a good fit, the benefits can be quite. So Zappa is a wrapper for deploying a Python-based application to Lambda. So what Zappa will do is basically it will package your application into a zip file. It will install that. It will set up a Lambda for you, and it will set up an API gateway for you. So when it is packaging it up, let me. So what I did now is I deployed my application using Zappa. So I have a new endpoint, I think. Yeah, so what I need to do. So what I did just now is that I told my bot that the Lambda URL is changed now. So it's no longer the previous one. And now it says, okay. Let's see what happens now. This did not work. It's because of a bug in my bot. Basically, it needs to be just 3 words, but I'm working on it. But again, you'll see how fast it is, despite having, there you go. So despite deploying it right now, you can see how fast it is, right? Are there any cons of serverless or any limitations? It's like I said, serverless is definitely not for all. Serverless is fantastic for very specific use cases. If you have an application which is running 24/7, serverless, the economics of serverless will mean that it is going to be very expensive for you, and you will have to figure out which is the good. Many containers can be present on a single machine, so how it decides how space to use for a particular application. Again, that is not something that we have to worry about. That is something AWS will take care of it, or your cloud provider takes care of it. But in case of let's say that you're running a serverless provider such as OpenWhisk on your local system, the application itself is built in such a way that it will you need to declare it ahead of time, saying that this application is this type, so it will bring up a new container for it. So 99% of the time, or rather, I'll actually say almost all of the time, a container is never used. Every time you invoke a new function, a new container is always spawned up based on the configuration. The AWS console panel can be a bit confusing, so I will try to keep it as simple as possible. So looking at the API gateway, Ganesh was asking what features API gateway provides. So you can see here, with an API gateway, you can set up authorization using API keys. So you can, if you have an endpoint which is public, and to prevent it from being excessively used or abused, what you can do is you can set up an API key so that only authorized users can access it. You can have multiple authorizers, and an API gateway for all practical purposes is just a big reverse proxy. So you can proxy the connection to anywhere else. You can have one API gateway and you can have multiple functions running on it, saying based on the endpoint, this function needs to be invoked. So if you see here, what happens is whenever a request comes here, what happens is there's an integration request, there's Lambda proxy, which says, so this Lambda gets invoked. And basically that's how it is. You can see the memory is set as 512 MB by default. You can change this if you want it. I don't think Postman is an API gateway, is it? It's basically an API client. So that's an example of how Lambda works. These are the integrations. You don't have to worry about this for now. We can, once you understand Lambda, you'll know how to work with it. Silpa was saying something about API. So you were asking what is an API? Okay. So when I launched the AWS console panel, right? You saw all of these. You see, you've seen this. So how does a web application get all of this information? So that is done using API. API is nothing but application programming interface. It's basically says that based on my request, give me something. Okay. So for example, when I say when I go to Lambda and when I say functions, what happens is this web app makes a call to an API, which is an endpoint, which says, give me a list of all the functions that this specific user has. And let me see if it is. So if you go to Chrome's debugger console, so you can see here, list functions. So this is basically an API call. And another API call is what I did just now. I used curl to make an API to Telegram, which basically said that earlier I had my bot talking to a different endpoint. Now I want you to change it, and an API is a programmatic way of changing things. For a service like Store Locator, which should be public and not set authorization API gateway, how can we use? The API gateway gives you options of setting up throttling limits. You can block. If you know that you can. There are ways of detecting bots using signatures, using the way they are making calls. For example, a lot of bots will not be having any user agents. So you can say any request which comes in from a request which does not have a user agent, just reject it. So there are ways of working on that, but that's another quite complicated topic and will be out of scope for this session. Yeah, and before I forget, so you can see here, if you go to monitoring, you can see how many invocations were run and how long the function ran. So it says 2 because when the function deployed, Zappa will call the function and see if it is okay or not. And the second function was obviously this one. And you can see the function took 2000 milliseconds, which is about 2 seconds. And yeah, you can set up throttling using this. You can see how many throttles were done. You can deploy multiple applications also on a single server without container. Yes, you can do it, but what happens when your second application starts acting up, if it starts consuming more resources? Now your other application also gets affected by this, right? So, but if you put it in, if you put it in a container, you can set up limits per container, and you can say that I want one container to have only 2 GB of RAM. I have not used Django REST API for this bot. This bot is basically just simple request library. For something this simple, I didn't need Django REST API. It's literally what 66 lines of code. That's about it. And I'm just using request to make an API call. And I'm using this free currency converter API to fetch the request. For something more complicated, Django REST API or maybe Flask makes sense, but I think for this it was just too much.
So this brings us to the end of this session. Let us quickly take a look at the pointers that we touched upon in this session. We started off this session by understanding serverless architecture and AWS services that support serverless architecture. Going ahead, we understood Amazon Lambda, that is a serverless service again, and we built a serverless application using Amazon Web Services and Lambda in particular. Finally, we did take a look at what containers are and how they help in serverless computing, and finish the session off by understanding who are the people and use cases that support serverless computing. Thank you.